This is lecture number 5 of this mineral processing class, and today we will look at a video which will explain you about the flow sheet of the mineral processing. That means starting from comminution to dewatering. In this video we can get it with details. You remember the first step is comminution, right? Size reduction. We start with size reduction. You can see these are the crushers and grinders. As you know, in the combination crushing and grinding, you can see the crushers how in crushing and grinding. This is a jaw crusher. It is a jaw, right? This is called conveyor belt. The material is transported from one location to another location. So this is again jaw crusher. This is a jaw crusher. This is actually a primary crusher. You can see the size of the feet, how big it is. This is now secondary crusher. Cone crusher, vibratory crusher.
Less than 0.5 cm. Cheap cigarette.
So this is ball mill. That means milling is done in this. After crushing is done, and milling, we are doing milling. That means grinding is done.
Wet grinding.
And if you remember, we do grinding in wet grinding, right? So it is always wet grinding, wet and cold grinding. But in crushing, we remember it is always solid. Dry crushing. But grinding is wet grinding. You can see the screens are there. See, those are screens. See, these are the screens. Size separation. We talk about size separation, sizing. You can see the screens. Oversize and undersize. If you remember, I talked about sizing in two types. You can do screening or we do classification. Classification is done in liquid form, that is slurry form. Then concentration process. This is magnetic separation, magnetic concentration. Anybody remember what is this? Sulfidation. Sulfidation is also a concentration process. This is electric separation. This is flow flotation. You can see the flow. Yeah. This is called jigging, actually gravity separation. So in the mineral processing, the first stage is as we know, that is combination process, right? And combination process is size reduction process. We have to reduce the size of the mineral or the ore, right? So the first we do crushing, right? Where our feed size is very big, but the product size is very small. Basically, we can have like in meter size of mineral. The size of the mineral, initial mineral will be in form of meter size, right? But the product you will get in form of centimeter. So first step is called crushing, and crushing have many steps. Like you can go for primary crushing, you can go for secondary crushing, you can go for tertiary crushing. Right? So each crushing has its own feed size and product size. So product size will reduce and feed size also get reduced if you move from primary crushing to tertiary crushing. Is it okay? Anyways, so the main important point is you have to remember, I told you about reduction ratio. How many of you remember? Can you tell me? Okay, can you tell me what is reduction ratio? Just hold on. What is reduction ratio? The previous class you have discussed. What is reduction ratio?
Which is always greater than 1.
You should be passed continuously. There should not be any backlogs. If you have backlogs, they will not allow you to sit also. So listen, be serious. Yes, sit down. And once you fail in the subject, you can never pass in the second time. I'm saying, so clear it in one go, at least. So if you are attending the class properly, then only you can write an exam. Otherwise, it is not easy to go through the books in one night and you can clear it. I'm saying. Reduction ratio means it is always feed size and the divided by product size. That means it is. I also told you it is never decimal. Always greater than 1, right? Always, because feed size is always bigger. Product size is always smaller, right? And reduction ratio, what is the advantage of having reduction ratio? I told you. You can save time, you can save money, which is very important for an industry. Right? And the most important is you can choose a particular machine, crusher, right? Because each crusher has particular feed size. If you remember jaw crusher, I told you 6:1. That means 6 inch should be the mineral size and the product size should be of 1 inch, right? 6 inch mineral you are fitting, you are getting 1 inch size mineral. I told you already, it's a very simple thing. It is very important, right? So reduction ratio is important, and the point is surface area. This is very important. So can you tell me what is the relationship between surface area and size? From the back, okay. I want answer from you. Yeah. What is the relationship between surface area and size of the particle or size of the mineral here? Is direct proportional, inversely proportional, or there is no relation at all? Can you tell me? Surface area, yeah. Direct proportional. It's inversely proportional. This is important. Sit down. Surface area and particle size, they are inversely proportional to each other, right? That means if I have a finer size, then surface area will be more or great or bigger or higher. So bigger size and finer size. Bigger size have less surface area, but finer size have more surface area. You have to remember. Finer you go, you are increasing the surface area. For example, you know people like in the aquabirds and all water purifiers, we are using activated charcoal, right? Because activated charcoal has more surface area. Those are fine particles, right? So finer is the particle, surface area will be more. So surface area and particle size are inversely proportional. So if we move from crushing to grinding, we are reducing the size. So what will happen to the surface area? It will increase, right? If you take, yeah.
Particle size is bigger, won't it occupy more area as compared to the particle size is less? Then how is it?
I am talking about in terms of mass, for example, or in terms of volume. Right? Suppose you are taking 1 kg of fine and 1 kg of coarser. Listen carefully. You are keeping constant mass here. 1 kg of fine particles, 1 kg of coarse particles. If you measure the surface area, then you have more surface area in the fine particles. But mass is same. Right? You consider volume also. What exactly happening? If you reduce technically if I am saying, if you reduce the particle size, what will happen? More number of dangling bonds will be there on the surface. a more number of atoms will be available on the surface if you reduce the particle size. But if you not reduce the particle size, it is bigger. So less number of atoms will be on the surface. Most of the atoms will be in the bulk.
Void source.
In the bulk. You understand my point? More reduce. Suppose I will reduce to one atom, single atom. So all the single atoms will be on the one layer of atoms will be there on the surface. Right? So finite is the particle, more surface area. Right? And similarly, what about reduction ratio? If I am moving from crusher to grinder, what happened to the reduction ratio? It will decrease or increase? Yeah, somebody is saying something. Yeah. Surface area increases if you move from crushing to grinding, right? But what happened to the reduction ratio? It will increase or decrease? Decrease. Because initial mineral size is very big, right? So obviously, if you are going to grinding initial size is small already. So obviously reduction ratio will be less. So in case of crushing, you have more reduction ratio, but in case of grinding, you have less reduction ratio. Obviously.
Yes.
Right? Because it is always feed size by product size. So these are the two important points. One is reduction ratio and the surface area. So that will decide also your law of crushing. I will tell you in details. But anyways, you can have, there is a crusher called jaw crusher. Jaw crusher. So what is this? This will be having one and like this. So this is like this actually. The crusher is like this. You guys see the video? Jaw crusher. So in the jaw crusher, it is like jaw. Jaw you have, right? Upper and lower jaw. So in upper lower jaw, what we are cutting, we are just cutting the whatever we are taking, right? Similar, this jaw crusher has one fixed jaw and one is movable jaw. For example, this is your fixed jaw. Fixed jaw means it is fixed. It will not move at all. It is constant, right? But this jaw is moving jaw, a movable jaw. Or some people call swing jaw. This is called anvil jaw. So this will move, but this will not move. So this will move in this direction. Oscillation, fine, like this. This will move. So when it will move, and you are feeding very big size particles, minerals, into this. So this is your feed end, no? This is your feed end, and this is your discharging end, no? Or product end or discharging end. Fine. So you are feeding this much size of material, and this is fixed, and this is heating, right? So what will happen? Your particle size will get reduced with time. Like this. Continuous reduction of size will happen. And you have to remember, in jaw crusher or in the primary crushing, the mechanism of crushing is compression. Just you are applying compressive force like this. You have the mineral and you are applying compressive force. And due to this compressive force, it is breaking down into fine particles. Okay? Is it clear? Yes. So in the jaw crusher, you have a fixed jaw and you have a movable jaw. A movable jaw is continuously heating the particles, or it is compressing the mineral particles so that it will reduce to smaller size. Okay? Fine? And if you remember, I told initial feed size will be nearly maybe 1.8 meter to maybe your 2.4 meter size is the feed size. So 1.8 to 2.4 meter size mineral you are feeding, but at the end how much you can get? Maybe you are getting 25 centimeters. You can see. You can convert this one into meter and you can find out the reduction ratio. This is in meter. You can convert it into meter and you can find out the reduction ratio. Reduction ratio is what? This size by this size. Okay? Fine. Feed size by product size. That is reduction ratio. Just you need to convert the unit. Either convert into centimeter top one, then you can do it. Otherwise, you convert into, or if you have inch here, also you can have inch here. You can do that also. Unit should be same, no? Of course. And here, exactly, 1,000 ton per day. So this kind of jaw crusher can crush 1,000 ton of material in the industry per day. You can imagine. Very efficient. Okay, fine. Here I can do more. So here there will be it's called toggle. This is called treatment. This is called eccentric shaft. Eccentric shaft. And actually you have this kind of arrangement. This is called flywheel. Can you share the image through WhatsApp? They can see. Satyajit, can you share the image? Can you share the images of this jaw crusher? I've sent you once. Just check. Or in the previous lecture I have sent you. Can you share it? So what are the parts, what are the components of jaw crusher? One component is called flywheel. So it has two flywheels. One is bigger and one is smaller flywheel. And in between the flywheel there is a shaft. Right? Listen carefully. The two flywheels, it's kind of a wheel, it rotates. So flywheel when rotates, the shaft will also rotate. Right? But the shaft is connected with the pitman. So this one is the pitman here. So here what is exactly happening? This rotational motion is converted into this kind of motion. Up and down. And finally, this is connected to this. So this will move in forward and backward direction, continuously hitting the mineral particles. So rotating motion is finally converted to oscillatory motion, forward and backward, right? And it is hitting the mineral and continuously crushing is happening. So you have flywheel, you have, this is called eccentric shaft, and you have pitman, you have toggles, and movable jaw and fixed jaw. These are the components of this. And you have to remember this jaw are actually made up of steel, but they have liners also. Liner means we give a line to it. Liner means it is so hard and tough. That is called liner. So here they have liners like this. So liners are made up of very strong steels, so that it will not break. It can absorb the energy also continuously. That's called liner. Okay, can end this.